cost curves are U-shaped. So we can show, this relationship in terms of cost also. So the variables that we will, take in charting the plots and understanding the relationship are, these are some of the variables. So just like, so we will divide the cost in two forms. First is fixed cost and another is variable cost. So fixed cost, as the name itself is suggesting, that it will remain fixed. We cannot change the fixed cost, so it will remain fixed. So fixed cost is the cost that does not vary with the level of output, and that can be eliminated only by shutting down. So if we completely shut down the business, then only the fixed cost can be eliminated. Otherwise it remains constant with the level of output. So say, for example, to make this thing very simple, you can think of an example. If you are operating your business, your factory on a rented property, so whether you are running that factory or you are not running that factory, the rent that you have to pay on that rented property is fixed. The rent amount is fixed. So that is a fixed amount that you have to make every month. So that is an example of fixed cost. And variable cost is the cost that varies as output varies. So if we increase the output, the variable cost also increases. So that component of cost is known as variable cost. And if we combine both variable and fixed cost, that gives us the third figure, that is total cost. So total economic cost of production consisting of fixed and variable. So if we combine fixed and variable cost, that gives us the third matrix, that is total cost. Then we have three more matrices. If we divide average total cost by the number of output or the number of quantity that are being produced, that gives us the figure of average total cost. Average total cost is nothing but the total cost divided by the number of output or the quantity of output. Similarly, if we divide the fixed cost by the number of output, that gives us average fixed cost. And if we divide variable cost by the number of output, that gives us the figure of average variable cost. The concept of shutting down is related with this, because shutting down does not necessarily mean going out of business. By reducing the output of a factory to zero, the company can eliminate cost of raw material and much of the labor. The only way to eliminate fixed cost would be to close the doors, turn off the electricity, and perhaps even sell off or scrap the machinery. So because every machinery has certain cost of maintenance. So the only way is to doing these things, then only we can eliminate the fixed cost. How do we know which costs are fixed and which costs are variable? Over a very short horizon, every cost is fixed. So say a few months, most costs are fixed. Over such a short period, a firm is usually obligated to pay for contracted shipments of material. So even raw material cannot be reduced or increased or reduced, because whatever raw material is required, we have already made payment for those raw materials. So in a very short period of time, every given input is fixed, and over a very long period of time, every variable is variable, every input is variable. So over a very long time horizon, say 10 years, nearly all costs are variable. Workers and managers can be laid off, new workers can be hired, existing workers can be laid off, employment can be reduced by attrition, and much of the machinery can be sold off, old machinery can be sold off, new machinery can be purchased and installed. and old machinery can be scrapped. So basically every thing can be changed, every input can be changed in a very long time horizon, say for example 5 years or 10 years, and in a very short time period every input remains fixed. So there is a middle way. So any period of time in which not everything can be changed is a short term period, and a time period in which every input can be changed, that time period is long time period. So both concepts are related with each other. We try to define the time horizon based on this differentiation of fixed cost and variable cost. And similarly, we also define the variable costs and fixed costs in terms of time horizon. Marginal cost, the concept of marginal cost is that increase in the total cost resulting from the production of an additional unit. So say for example, if we are currently producing 100 units of any product, and we decide to produce one more unit, just one more unit, what is the extra cost associated with the production of that extra product? The change in the total cost resulting from one additional unit of output, that is called marginal cost. So marginal cost is the cost resulting from the production of one extra unit of output, because fixed cost does not change. चाहे हम 100 यूनिट प्रोड्यूस करें चाहे 101 करें, the fixed cost remains constant, remains unchanged. So that is why as the firm's level of output changes, marginal cost is equal to the increase in variable cost or the increase in total cost that results from an extra unit of output. We can therefore write marginal cost as, so marginal cost can be written like this, which is change in variable cost divided by change in quantity. Similarly, we can also write change in total cost divided by change in quantity. So if the change in quantity is only 1, so the denominator will remain 1. But if the change in quantity is more than 1, then then we have to use the denominator also. And since the fixed cost is constant, so whether we take total cost or whether we take variable cost, both things means same. So the change in variable cost is known as marginal cost, or the change in total cost, whether we use total cost or variable cost, it means same thing. So just to check whether you understood this concept or not, this is a quiz in front of you. So suppose Maruti's total cost of producing 4 Alto car is 2,25,000, and its total cost of producing 5 cars is 2,50,000. What is the average total cost of producing 5 cars? So first you have to answer what is the total average cost. So for calculating average cost, total cost
upon quantity.
Upon quantity.
Yes, sir. So 50,000.
50,000.
50,000.
50,000.
Okay, 50,000 is correct answer. So 2,50,000 divided by 5. So this will gives us a figure of 50,000. So this is what? This is average total cost. Average total cost. Now coming to the second question, what is the marginal cost of the 5th car?
25,000.
25,000.
25,000.
Okay, 25,000. So the formula for calculating the marginal cost is change in total cost
Upon change in quantity.
upon change in quantity. So change in total cost is 25,000.
Yes.
25,000.
And change in quantity is how much?
One.
One.
5,004.
So this will gives us the same figure of 25,000. Okay. So this is a table which demonstrates or which shows the law of diminishing returns from the angle of costs. Just keep this fact in mind that the same relationship that we have studied in terms of product, total product and average product and marginal product, the same. This is the just mirror image of the product behavior. If the product was increasing, it also means cost was decreasing. If the product was decreasing, then it means cost is increasing. So look at these figures. Just take your time and just give me 1 minute. I will continue. Okay, so the first column is for the number of outputs. Now the rate of output per unit, units per year. So 0, 1, 2, 3, 4, 5 up to 11. And the second column is for fixed cost. And as per the definition, fixed cost will remain constant. So it is 50 and it will remain 50 till the last point of data here. And the third column is for variable cost. And this is 0, then 50, then 78, and it is increasing till 385. Then we have total cost, which is the sum of column 2
Fixed
and column
cost and
3.
variable cost. Yes, sir.
Yeah, fixed cost and variable cost. If you sum these two figures, the third column has been generated. And marginal cost is the change in the variable cost. So here, say for example, from 0 to 50, the variable cost has increased from 0 to 50. So marginal cost will be 50. Then from 50 to 78. So the change from 50 to 78, how much is the change? 28. So since the rate of change in the output is only 1, 2, 3, 4, 5, so like that. So we can ignore the denominator and we can just focus on the change in the variable cost. So 78 to 98, the change is 20. So like this, the marginal cost has been calculated. So marginal cost has been calculated simply by change in variable cost. Change in variable cost is marginal cost in this case. Similarly, this column, that is average fixed cost, if we divide the fixed cost by the number of unit or number of output, that gives us average fixed cost. And the behavior of average fixed cost you might observe here is that it is reducing. Initially it was 50, then it became 25, then it became 16.7, then it became 12, then the last figure is 4.5. And this is because the numerator is fixed and we are increasing the denominator, because average fixed cost, what is average fixed cost? Average fixed cost is fixed cost divided by Q. Fixed cost divided by Q. So if we keep increasing Q, so the resultant is supposed to decline or decrease over. The more we will increase this Q, if we keep increasing this Q, the output will keep decreasing. So this is what is happening here, because fixed cost is constant. This component is constant, and we are increasing this as this the denominator, that is the quantity or the unit of output. So that is why the behavior of average fixed cost is that it will keep reducing like this. So if the graph is like this is average fixed cost. Average fixed cost. So initially it will be very high, then it will start increasing, and it will be like this. Just to check, whether you are listening or not, just to tell me whether this line will go in the negative territory or not.
No, sir.
No, sir.
No,
Never.
sir.
It will tends to the
Okay, this can become very less, but it cannot become negative. Okay, thank you very much. Now the next column is for average variable cost. Average variable cost is nothing but variable cost divided by number of unit. So initially, this will reduce, then it will reach at its minimum. Then after reaching its minimum, it will start rising. So the shape of average variable cost is U shape, that initially it is reducing, then it will reach its minimum, then it will start rising like this. So this is the shape of average variable cost, that initially it reduces, then it reaches its minimum, and then it starts rising. So this is how average variable cost looks like. Average variable cost. And the last column is average total cost. So average total cost is the sum of fixed cost and total cost divided by number of
Quantity.
output.
Output.
Yes. So let us look at the graphs, how they look in the form of graph. So you have two plots in front of you on your screen. The first one plots the total cost and variable cost. You might observe here that in the plot that is on the upper side, we have one line for FC. FC is fixed cost, and this fixed cost is constant. Fixed cost is constant. So this is constant. This is like a straight line, because in the example also you might have seen that it was 50 and it remained 50 irrespective of the level of output. So whether we are producing 1 unit of output or 5 or 10 or 11, it will remain constant. So this is a straight line. And then we have a variable cost curve. So variable cost curve is starting from 0, because when the level of output was 0, the variable cost was also 0.
So when the level of output was 0, the variable cost was 0. So that is why the variable cost curve is starting from this point, that is 0.
And this TC, that is total cost, or you can also call it total cost. That is total cost. So total cost is the sum of FC and VC.
So if we combine FC plus VC, so as you know that fixed cost plus variable cost is equal to total cost. So this this relationship, that is fixed cost plus variable cost, is equal to total cost. So graphically this relationship is visible in this plot also, that here the total cost is of the same shape. The only difference is that it is starting from this point, that is 50. So total cost curve is the summation of variable cost and fixed cost. So in this curve,
what is the feature of this curve? That is variable cost. Variable cost initially increases at an increasing rate.
At a decreasing rate, sir.
At a decreasing rate, then it starts
increasing at an increasing rate. So initially it increases at a decreasing rate, then it starts increasing at an increasing rate. This is the behavior. Now coming to the plot which is there on the lower side, which plots marginal cost, average variable cost, average total cost, and average fixed cost. So first, let us look at the AFC. So as we saw that fixed cost, when it is divided by the quantity, it will keep reducing. So this is what is happening here, that average fixed cost,
initially it was around 55, then it is decreasing and decreasing like this, and
it will go on like this. So this is average fixed cost. And as far as marginal cost and average variable cost is concerned, marginal cost initially will decrease
like this. This is the red one, is the marginal cost, and then it will start increasing, and it will cross the average variable cost and average total cost curve at its minimum point. So this point, the point where it is crossing the average variable cost curve, is the minimum point of average variable cost and average total cost. So this is the point that you have to keep in mind, that marginal cost curve
cuts average variable cost and average total cost at its minimum point. So when marginal cost curve becomes, crosses the average variable cost,
the average variable cost also starts rising. So beyond this,
यहाँ तक तो if the variable cost was decreasing, the variable cost was decreasing. But once marginal cost has increased, marginal cost has crossed the average variable cost,
the average variable cost will also start rising. Similarly will happen with average total cost also, because average total cost is nothing but the summation of average variable cost and average fixed cost. So this is law of diminishing returns. Why this is law of diminishing returns? Because beyond certain point, the average variable cost has started increasing, and beyond certain point, the marginal cost is increasing at an increasing rate, and initially it is decreasing, but after some point of time, the average cost per unit has started increasing. So this phenomena is called diminishing returns, or law of diminishing returns. So the point
that happens only when this graph you are telling us that this is only for this particular data, or always it will happen?
Yatendra, your name is Yatendra?
Yes, sir. Yes. Can you hear me?
So wherever any relationship is there, for example, the law of diminishing returns. So economists have they did research and they found this kind of relationship in a lot of industry. Just like I have given you example from farming, that say for example the land is fixed and you keep increasing the fertilizer. So to some extent the output will change, the output will increase, but beyond a level, if you further increase the fertilizer, the output will not increase, and actually will start decreasing. So, and the same phenomena has been observed in the software industry also. So, this is, so whatever, is the average
observation of economists, that is, we study those relationships. So this relationship has been found in a lot of industries, in a lot of contexts. So what is the actual reality in a particular industry, say for example in lock industry in Aligarh, or in brass industry in Muradabad, or in silk industry in Banaras, or whatever. There are different, small industries, big industries. So we can study the actual data, and we can
arrive whether they are experiencing the diminishing returns to scale, or they are experiencing increasing returns to scale, things like that.
But this is the theory, and every theory is formed on the basis of evidence. So since economists have found evidence, so that is why we try to understand them. And if we are interested in analyzing any industry, we can analyze in light of these things
in this framework. So this is the benefit of understanding and studying these things. Okay, thank you very much for.
Excuse me, sir.
Okay.
Hello.
Yes.
Thank you, sir.
Sir, I have a question from the yesterday's session, sir.
Okay, you are Lokesh?
Yes, sir, Lokesh.
Okay,
Sir, actually, you discussed about the plotting of the total product curve by using the Excel. But we get that, but we were not able to estimate the short-term production function related to that case. That in that case, you use the regression and so many things. We were not able to get that points. What were you discussing about the regression and the production function of the second order?
Okay, so regression is nothing but is a relationship between X and Y. The relationship
between X and Y is known as regression. So Y is equal to A plus BX.
Is this very clear? Y is equal to A plus BX.
Yes, sir. Yes, sir.
So this is also the standard function, right?
Yes. So this can be, a line like this, a line like, this, or a line like this. So it can be any line, isn't it? So any line means linear relationship. That if X is increased by 10%, Y will increase by 12%. Or if the change in X is equal to the change in Y, if we are increasing the X by 10%, Y is also changing by 10%. In that case, this line will be a 45-degree line like this. A 45-degree line will be there, that
whatever change in Y is happening, that is proportionate to the change in X. The change in X is equal to the change in Y. So this will be a straight line. But in case of the diminishing returns, the straight line is not the case.
because we are increasing the input, but the output is not increasing at the same rate. The output beyond a certain level has started declining. So in that case, a linear relationship is not suitable between X and Y. What is X and Y? X is the input, Y is the output. So in the example that we have talked about, fertilizer is the input and number of bushels is the output. So the relationship between fertilizer and number of bushels is not linear. So if we are increasing the fertilizer by 10%, the output is not increasing by 10%. So it means the relationship between X and Y is not linear. So that is why the straight line is not a suitable thing to describe the relationship. So in that case, the polynomial regression is more suitable. So polynomial means, when we include here x square, a plus bx plus cx square. So square item. So this can be negative also, this can be positive also. So this kind of equation is called polynomial equation or polynomial regression. So in case of diminishing returns to scale, instead of a linear equation, a polynomial equation describes the reality in a better way, because in that equation we have compared R square. R square basically means regression fit. Visually also, you might have observed that a straight line is actually not there is a difference between that straight line and the actual curve. But when you have used polynomial regression, that curve is actually closer to the actual data. So the fit is more. So the fit is measured in terms of R square, and R square of the polynomial regression is more, that is 99%, and R square of the straight line or linear equation is less. So we can say that the relationship between input and output is not linear and is polynomial.
Yes, sir, we got it. Thank you, sir.
Yes, sir, it is understood.
Thank you, sir.
Thank you, sir.
Thank you, sir.